All right, so hi everyone. We are super excited to be connected today. Welcome in this webinar dedicated to FiRa Consortium 3.0 certification program. I'm Benjamin Guillou. I'm the chairman of the marketing working group of FiRa Consortium. And today we have for you an amazing list of speakers. Indeed, in 2 slides, please, Samantha, we will see the agenda. Yeah, next slide, please. Indeed, first of all, Michael Stark, our co-chair of the Certification and Conformance Working Group, will start with a brief introduction about the new core features and the use cases that they support. Then Michael will continue with the ultra-wideband certification offered for car connectivity consortium. Then our FiRa Consortium certification program manager, Jacek Hruszkiewicz, will continue with FiRa 3.0 certification program itself. Then Tushar Patel, Business Development Manager at LitePoint, will talk about the fight testing. And last but not least, Zuzana Paley, Department Director of the Certification Center of Comarch, will continue about and finalize the talk with MAC testing and interoperability testing. You need to know that all along this webinar, you will be able to write all your questions in the chat box so that hopefully we will be able to answer them all at the end of the session. Next slide, please. Again, Michael, Jacek, Tushar, Zuzana, and I, we are all super happy to be here for you and hopefully provide you with valuable information about FiRa 3.0. So hope you will enjoy, and it's now time for me to hand over to Michael. So Michael, please, the stage is yours.
Thank you, Benjamin, and also warm welcome from my side. My name is Michael Stark, working for NXP. Today speaking in my capacity as FiRa CCWG co-chair. So let us go into the new core features we are aiming here to release in the FiRa 3.0 core certification release. This page looks good and full for you, hopefully. Let's introduce it and go step by step over it. And in order to introduce the FiRa 3.0 core features, I have to go back also to the FiRa 2.0 features and its associated use cases. 2.0 introduced also two-way ranging to measure distances between two devices, which allows to enable a use case like residential access. Then we also released convention-based ranging using two-way ranging. And this feature allows to discover devices and measure the distance to those. This enabled use cases like find something nearby. Then we also had the one-way ranging downlink time difference of arrival OWR DLTTOA. That's the more familiar name, where an infrastructure of anchors is sending out messages and a tag or a phone is using this information to determine its relative position. And this can be used for applications like indoor GPS, let's call it. You can determine your position indoors where no GPS is available. Finally, one-way ranging angle of arrival measurement, OWR AOA. Here, a device is sending out ranging frames, and the receiving device can use it to determine the relative angle to this other device, which can be used for point and trigger applications. Now, what's coming in FiRa 3.0 as core features? The main features are free, but there are more of it. Let's go with a big feature is called hybrid UWB scheduling. What does this feature do? It allows to organize sequentially and in a deterministic way different FiRa features, and thus allows to go into more complex use cases. Which use cases can be addressed? I will come there in a second. Let's first go into MAC data transfer feature. Here we are assigning specific exclusive airtimes just for data transfer. For data transfer, we have three modes: bypass, where the whole protocol layering has to be taken by the application. Connectionless mode, which allows a simple and slim protocol overhead to transfer data, and then connection-oriented, which is the full-blown, which allows a lossless, acknowledged data exchange. I will park the last feature, CCC Digital Key UWB, for a second. Before I go into the 3.0 use cases, I would like also to mention some other features which are not main features of the core release. One is the transmit signal quality. It's a 5-layer test case we could enable, and it ensures that the UWBS transmits pulses of a frame within the specification limits. So the quality of transmitted pulses within a frame. The second is FI security configuration testing. This feature ensures that the UWBS is robust against attacks on the physical layer of the protocol. So those are sub features, but worth to mention. Which features now FiRa 3.0 enables? And you can see here in the middle, the orange bar going down and the light gray bar going also to the FiRa use cases. So what I would like to show in this slide is, yes, using this HUS feature, we can combine 2.0 and 3.0 features in order to enable use cases. And as you can see, those use cases are more complex use cases, like public transport fare collection, where you have to use downlink TDA to navigate through the station, then contention-based arranging to discover the devices in front of the gate, and then finally data transfer to execute the fare collection transaction. Similar, also tap-free mobile payment uses some of them, those features like two-way ranges or contention-based ranging for discovery and distance measurement, and then make data transfer, all enabled via this HUS feature. Same thing is with logically access. Logically access, we have two-way ranging HUS and make data transfer that you can, the device, a personal computer, for example, can determine that a person with its phone is approaching and then also has the rights to unlock the personal computer. So then only the last feature is missing. Therefore, I would like Cement, I think, to go to the next slide. Yes, so this feature has been introduced for CCC, and FiRa, we have the opportunity and to introduce this the certification for this feature. Its name is CCC Digital Key UWB. The use case, the car access use case, is defined by Car Connectivity Consortium as a joint work. FiRa and CCC have founded the JUMP working group. It's a collaboration to enable the UWB in the digital key solution for this use case. With regards to the certification program, JUMP defined the test cases for FI and Mac with the aim to reuse as many material as possible on test cases already defined, with the aim to avoid any duplications. And also this has a reason, because at the end, nobody wants to, a UWBS or a vendor who has a UWBS certifying FiRa and CCC functionality does not want to go into duplicated test case execution, which makes also this concept of inheritance for this feature very important. How about responsibilities? Maybe a quick word on it. FiRa CCWG reviewed the test cases, made sure that our test tool vendors implemented it in the correct way, validated the test cases and the test tools, and now finally we also have the ability to offer certification for this CCC Digital Key UWB feature which should finally be successfully enabled in the car access use case. With that, I'm finished with the overview, and I would like to hand over to Jacek to give you an overview on the certification program. Thank you.
Welcome, everybody. My name is Jacek Hryszkiewicz. I'm Certification Program Manager at FiRa Consortium. So can we go to the next slide? Thank you, Samantha. Okay, so I want to start with giving you a couple of important high-level information about our certification program. This program defines processes that verify candidate devices against FiRa requirements and test specifications. It is aimed at driving interoperability between UWB devices. It's worth to mention that FiRa certification is only available to members of FiRa Consortium. There are a couple of membership options. You can find this information under the link provided here. And certification testing must be run on test tools that have gone through FiRa validation process. That's why we call them FiRa validated test tools. Devices must be tested by independent FiRa authorized test laboratories. And this all ensures that the whole certification follows the FiRa certification and testing requirements. A device must pass all applicable test cases to be certified, and applicability of the test cases is taken from the document called TRSL. It stands for the Test Requirements Status List. This document, in concert with the PICs, is used to generate a device-specific testing plan, and the device is certified to a specific current version of the TRSL. Oh, and of course, the FiRa certified logo can be used only by devices that fulfill the criteria of the certification program. Next slide, please. With the introduction of certification release 2.0, FiRa starts to offer a feature set certification. A feature set is a combination of a feature component and one or more device roles. And depending on the targeted use case, a device can claim conformance with at least one of the presented here feature components. So time schedule-based two-way ranging, contention-based one-way ranging, hybrid, MAC data transfer, or even CCC digital key UWB. And as you can see, last three are the FiRa features newly added in 3.0 release. And depending on the chosen feature component, a product may claim to support different device roles like controller, controllee, anchor, tag, advertiser, observer, device, or even vehicle. And this results in the feature set aimed for certification. Let's move to the certification options on the next slide. So FiRa offers different certification paths for devices. The most common one is the first one listed here, called initial tested device. And this certification approach requires testing for all supported features. And since some devices may be similar to other devices that have already been certified, FiRa provides the certification options which allow the reuse of certification test results. And these options are clearly described on the presented right now slide. We have recertification, variant device, rebranded device, and modules. And the amount of testing required for these paths is each time determined by the certification body. Next slide, please. So FiRa has created a simple process for device certification. All process is available in the FiRa certification management system, starting from step one, which is submitting application. This is a step where vendor provides key information about the device to the FiRa certification body. Step two is for certification body to review the application and approve it, or if needed, ask for some more information. Once application is approved, there is a time for the vendor to select the test lab from the list of FiRa authorized test labs. Having this done, vendor have to ship device to the chosen test lab. And then the authorized test lab will execute the required certification testing and provides logs to the certification body. And if the device passes, then vendor will pay the device certification listing fee and receive the FiRa certificate. Now a couple of words about certification management system. So let's move to the next slide, please. As described on the previous slide, FiRa certification management system is a web page that works as an interface between vendor, certification body, and ATL. The system implements the online version of the PICs. It is used by the vendors to declare the device supported features. It generates configuration files for the testing tools. These files have to be used by the ATLs during the certification testing. CMS also stores the certification testing logs that are uploaded by the ATLs for the certification body review. At the end of the certification process, the CMS can be also used to update the certified device list on the FiRa public web page. Next slide, please. Okay, so as you may imagine, FiRa is evolving all the time. New features are added and new versions of the specifications are released. As it is easy for the minor changes, it's not for the major ones. We need a mechanism to control smooth transitions between major releases, and that is why grace period has been introduced. And this is 180-day overlap when vendor may choose one of the two versions of the TRSL for certification. After that time, the previous older version will be expired and may no longer be used for the certification. Next slide, please. The current list of authorized test labs is shown here and can also be found on the FiRa website with the link provided here. On the next slide, we'll see the current list. Yes, please move to the next slide. Thank you. So the current list of FiRa validated test tools is shown on the slide. And this also can be found on the FiRa website at the link shown here. Please move to the next slide. Okay, so I'm pretty sure this is the last slide. So on this slide, I would like to touch the certification cost. Total FiRa certification cost is sum of two factors. First is a cost for testing in the ATL, which is a B2B negotiation between ATL and vendor. And listed here, the FiRa listing fee, which depends on the certification option. Thank you very much. And I will right now move the stage to Susanna, I think. Thank you.
Hello, everyone. Thanks for joining this CCW. Thanks for joining this session. My name is Tushar Patel, Business Development Manager at LitePoint. I'm going to go over some file testing summary. As you know, FiRa enables a lot of security and location-based use cases that requires the interoperability between the devices. FiRa Consortium also defines the file technical requirements to ensure the interoperability and the RF performance of the FiRa-defined use case. As you can see, with any wireless technology, which are based on the OSI models, it starts from the file layer and we go all the way to the services layer. For today's webinar, we are focusing on the PHY and the MAC certification. FiRa PHY is based on the IEEE 802.15.4, 4Z, and the upcoming 4AB standards. Currently, the scope of the FiRa certification is based on the 4Z standards. Now, as you can see, IEEE specification already defines some of the basic RF requirements. FiRa Consortium built onto those requirements and has added some more requirements which are specific to the FiRa-defined use cases. In the next slides, we'll go over those test cases. So if you look at from here, from the device maker, so what is expected from the certification perspective? So if you're a device maker or an end product manufacturer and wondering about how do I go about this FiRa certification process, what are the prerequisites for me to certify my devices. So start with that. The very first thing as a device maker you need to do is to make sure that you do support the UCI interface, which is a universal camera interface purely defined by the FiRa Consortium. That's the interface designed to talk to your UWB devices. And the physical interface to do that is a virtual COM port. So those are the two prerequisites requirements are placed upon to go for the FiRa certification. Once you do that, then you can wonder about, can I pre-test my devices? Of course you can. You can go to the FiRa website. FiRa has listed down all the FiRa validated test tool. You can acquire the softwares from the test tool vendor, and you can pre-cert your device before you go for the official certification process. Once you do that, then you go to the certification CMS website. You choose your certification TRSL version. You submit your device, you select the authorized test lab, and from that point onwards, certification program manager will follow with you with each and every step until your device get FiRa certified. And once you do that, you will receive the FiRa certification that you can use. Now you should be able to use the logo on your devices. At the certification test labs or the ATS, the typical setup looks like you would have one of the FiRa validated test tool. In this case, we are showing a LitePoint test tool. And then ATL would have access to the FI conformance test tool from a test tool vendor. And then the setup looks like something similar. You would have an RF connection that can be cable most of the time, but if you have over-the-air connection, that's also available at the certification program. And then typically as your UWB devices, you would definitely have the support for the UCI and the VCOM interface. You will simply connect, lab will simply connect device over the UART, and then we start running the test. Now we go into details about what kind of tests are being run at the certification lab. So if we look at the test, as I mentioned before, FiRa physical layer is based on the 802.15.4G spec, which is the IEEE spec for ultra-wideband technology. And the specification, their basic requirements are specified, and FiRa has built onto the top of those requirements. So if you look at the transmitter requirements are pretty straightforward. You would have a packet format check, which just validate each portion of the packet, like preamble, STS, SF3, and the payload. You would also validate the baseband impulse response, which is your pulse shape. We would also validate the timing between your symbol clock and the CFO. MRMSE is very unique measurement to FiRa Consortium, as IEEE has not defined any TX quality measurement. So FiRa Consortium has worked with the members to define EVM kind of matrix, which validate the accuracy of the pulse, which stands for normalized root mean square error. As the UWB is very specifically used for security, there are also some 5 security test cases like first part dynamic range, and the Hamming distance test are also available. What's new in FiRa 3.0? So FiRa 3.0 includes a certification for CCC digital key UWB certifications. It also enables certification for the FiRa security test cases. And we also enable the certification for the NRMSE test. So as you can see, all the 5 measurements are very detailed and very comprehensive way of validating that the FiRa compliance devices stick to the requirement. And with that, I'm gonna end my presentation and hand off to Zuzana Pales from Comarch. So we'll go over for the MAC requirement and the IOP. Thank you.
Thanks, Tushar. Hi, I'm Zuzana Pales from Comarch certification team. And for a few minutes, I would like to tell you about the news in the test tools provided by Comarch. Since 2020, Comarch has been developing the MAC conformance test tool, which enables testing devices for compliance with FiRa requirements for the MAC layer of UWB communication. Compared to the previous version, the architecture of our test tool remains unchanged. However, we have introduced several updates. So related with the software, we have implemented some updates in our framework. We also launched the flashing utility to reduce the time needed for flashing hardware with the latest firmware. Testing the latest FiRa 3.0 features is now supported on the new version of hardware, which is MCCT ranging devices 2.0. this type of hardware were launched last year. And based on the test specification, we have added 167 new MAC test scenarios, including 84 test scenarios for CCC Digital Key 3.0 for the UWB testing. And once you are interested in testing only this feature, it is available, and our framework provides the functionality that you can choose only one feature that you are interested in testing. Overall, we have more than 250 MAC test scenarios available. On the next slide, a few words about the environment and requirements for the end users of our test tool and requirements for the DUTs. So to run the testing and the certification of MAC layer, you need to possess the test host because the application is a desktop application that works on Windows 10 operating system, and the test host communicates with the device under the test and with the Comarch hardware using USB ports. Here we have also a set of Comarch hardware, the ranging devices 2.0. Those hardware are simulating real FiRa devices that interacts with the DUT in order to do the ranging. The ranging devices capture UWB frames received from the DUT and pass them to the test scripts for analysis. Various units are utilized during the test execution. So for some feature, you need to use only one unit, and some of the test scenarios used up to 5 units of ranging device. When it comes to the DUT, this is the UWB device that is tested for compliance with the FiRa MAC specification, and DUT is connected to the test host using a serial connection over USB. This communication is maintained to exchange FiRa UCI protocol message in order to send the ranging configuration to the device and to receive the notification. The final step is preparing a PIX file for the DUT. And for the vendors testing their devices, the file can be created manually. You can use our sample file that is included to MCCT installation and change some aspects of this file. And for the certification purposes, the PIX file must be downloaded from the FiRa CMS website. And on the next slide, you can see some of benefits using MCCT for development, because it is not only tool for the certification. MCCT plays an essential role during the development. It helps to ensure the devices align with the FiRa standard before formal testing. So you can use MAC test tool during the development process, and it provides a controlled environment for simulating roles and configurations. For example, once you can test a mobile part, and once you can change it to vehicle. And so the MCCT application supports efficient debugging and real-time diagnostic to address all the issues that may appear during the development. As FiRa specification involves, Comarch provides to users the regular updates, and you can test the latest functionalities on the test events with other FiRa members. Moreover, you can always rely on Comarch support in interrupting the test results. When it comes to the IOP testing, it is really similar. Can we go to the next slide, please? Our test tool, ITT, verifies the interoperability and functional consistency of devices from different manufacturers to support FiRa-defined use cases. For FiRa 3.0, we have implemented 50 new IOP test cases, and overall we have 140 test scenarios that is supported by the new version of hardware ITT device 2.0. It is available since 2023. And on the next slide, you can see that the architecture is similar to the architecture and the environment for Mac conformance test tool. The easiest way to describe is to compare it with the Mac testing. So if you have the DUT, the requirements for DUT are pretty the same. We still need PIX file, and we still communicate with the test host using UCI protocol. And the test host with Windows 10 operating system is connected to the ITT device and the reference device. The DUT interacts with the reference device, and unlike to the MCCT ranging devices, the ITT device does not take an active part in ranging. It serves like a UWB sniffer that knows the ranging message that knows the ranging message schedule and listen the frames which are expected to be transmitted. ITT device includes different test scripts, and the key difference is that it communicates with the reference devices, and you can add to the test environment up to 8 reference devices. For the certification purposes, you need to use the official reference device that is listed on FiRa website, and for the debugging or testing purposes, you can use your own device or other Comarch device. And on the next slide, please. Similar like with the MCCT, IOP testing can be a great step to implement it into the development process because it helps to prepare devices for the real world deployment. It can help us solve IOP challenges and accelerate time to market. Similar to MCCT, as the FiRa specification evolves, we are providing regular updates, and the latest functionalities can be tested during the test events. And I know that the testing interoperability between devices from different manufacturers can bring a lot of excitement, as well as can bring us interesting results, which, if needed, Comarch can help to interpret. And this is all from my side. Let's go to the Q&A section, and Benjamin will continue.
Thank you very much, Zuzana. Indeed, so let's continue with the Q&A session, and I think there's already one very good question from Franz Dugan. So the question is the following one, and most probably for Jacek. So the question is, once you certify for a certain version of the TRL, how long is it valid for? Is there a deprecation after a certain time forcing the device chip to be recertified with a newer version of the TRL? So I guess, Jacek, you can answer this question, right?
Yes, I will answer this question. So thank you very much for this question, Franz. It's a good question. I think I missed this information in my presentation. So as you certify the device with the specific firmware, hardware, and software version to the specific version of the TRSL, the certification is valid always for this product version and TRSL version. And FiRa does not force the recertification, so it's up to vendor to recertify its device to the newer TRSL or with the newer device version. Hopefully this answers the question. Thank you.
Right. And it seems that the team, you guys made a great job because this was the only question we had. So hopefully the presentation was very clear for everyone connected. So maybe we can still use 1 minute in case someone still wants to ask one last question. Otherwise we will switch to the next and last part of the presentation. Okay, so no further question. What's next? In order to learn more for you, obviously, you can find plenty of resources at the FiRaConsortium.org website, whether you want some more information about the certification process, or for example, if you need assistance, Jacek will be happy to help. You have the formal email address here for the certification program manager, so Jacek himself. And for any other general question, you have the general admin email. You can also, on the next slide, please, you can also see additional ways to get in touch with the companies from the presenters. So general email address from Comarch here, and personal email address from Tushar. Additionally, Michael and other co-chairs and other members of the certification and compliance working group will be happy to answer some question, and you can leverage that email address as well. And regarding marketing, meaning technological deployment, business development, or any additional promotional consideration, feel free to use the marketing@consortium.org email address, which is the formal mail address from the marketing working group of the FiRa Consortium. So it's now time for us to thank you very much for connecting. We hope that we will see you again in the future webinars or even in the future face-to-face session of the FiRa Consortium. If you are already a member, then we will be happy to see you there. If you are not a member yet, then we are looking forward to welcoming you with open arms at the FiRa Consortium. Thank you very much again for connecting, and see you soon. Bye-bye.